So we were started with the rheology chapter, and rheology is very important chapter again. So we have seen the important point from rheology, but again I would like to revise, and today I will finish this chapter because we have to deal with a lot of syllabus. First of all, what do you mean by rheology? Rheology is the term which is related with the flow of flow of fluid or flow of liquid. So particularly rheology is nothing but the flow of science. So it is derived from two words. The term rheology, it is obtained from two words. That is, first one is rheo, rheo means flow, and logos means science. So it deals with the study of flow of liquids. Now this was suggested by Bingham and Crawford, and that's why the rheology term was suggested by this Bingham and Crawford. So again, particular type of body, a particular type of material which show plastic flow, they are known as the Bingham bodies. Okay, we'll see in upcoming part. Now, in case if you apply a particular force or particular stress on liquid, it will start flowing. If you apply a particular type of force on the solid, so solid it will deform. Solid के ऊपर अगर force लगाया तो solid क्या होगा? Break down होगा. Now deformation of solid will be there, and in case of fluid there will be flow there will be flow. Now the type of flow and the science of flow is nothing but the rheology. Okay. Now in the solid also you have, if you apply force there is a deformation. In that also there are two type of material, plastic and elastic. Some material upon application of force they will deform. Okay, and they will deform permanently. They are known as the plastic bodies. Okay, some material they will deform. Okay, if you apply force to them they will not deform, but they will behave like a deform. Okay, and upon removal of force, so they will regain their position, known as a elastic material. Okay, now what do you mean by this? This rheology has very much application in the pharmaceutical sciences, because we have to deal with the solution, suspension, okay, emulsion, creams, paste, etc., etc. We have to deal with the different polymers, their flow. Okay, say for example carboxymethyl cellulose polymer, है ना? micro okay, micronized carboxymethyl cellulose, that is used as a eye drop to lubricate the eyes. So that is also important. So flow of fluid is involved in the mixing, also in the tableting process, also in the capsuling, also mixing. Okay, then transportation of fluid in that. So preparation of solution, suspension, emulsion, spreading of ointment, creams, paste on your skin. So that also involves the rheology, right? What do you mean by viscosity? Viscosity or dynamic viscosity or absolute viscosity is nothing but the resistance to the flow. So whatever resistance is there to flow a particular liquid, known as a viscosity. Now more is the viscosity, less will be the liquid flow. Less will be the viscosity, more will be liquid flow, right? So viscosity ultimately indicate the molecular weight as well as the bonding present in the molecules of that liquid. Okay, so it is nothing but the resistance to flow, viscosity. Now SI unit of viscosity is nothing but the poise. SI unit is nothing but the poise, and 1 poise is equal to 10 raised to minus 2 centipoise. You have to remember. Now what is that viscosity? It is nothing but the it is nothing but the shearing force required to produce a velocity of 1 centimeter per second between the two parallel plane of liquid in the 1 centimeter square area separated by a distance of 1 centimeter. Now it is nothing but the viscosity is nothing but the shearing force which is required to produce velocity of 1 centimeter per second between the two parallel plane of liquid having 1 centimeter square surface area at a distance of 1 centimeter. That is the definition of viscosity. Now liquid is considered as a made up of a different planes. Now if you try to apply stress, so it will move in the plane. Okay, so that's why. Then kinematic viscosity means, kinematic viscosity is, it is nothing but the ratio of absolute viscosity to the density of the fluid. So जो viscosity है उसके उसको divide करो density, viscosity divided by density, that is nothing but the kinematic viscosity. Its unit is nothing but the Stokes. Okay. So Stokes and Centi-Stokes. Rheology is nothing but the flow of liquid and deformation of solid. The study of flow properties is very important in case of liquid oral gels, ointments, cream, paste, etc. etc. Right? Because these things or these formulations we are going to deal with the these formulation in the pharmacy. That's why. Now, flow behavior of liquid on application of stress. Flow behavior of liquid on application of stress is nothing but the rheology. If you apply particular force to a liquid, so how it will behave, whether it will flow immediately, whether it will raise the flow, or whether it will increase the viscosity, there is a decrease in the viscosity upon application of stress. So that flow behavior of liquid upon application of force or stress is nothing but the rheology. Now, flow of liquid, it can be expressed quantitatively in the term of viscosity. In the term of viscosity. ना आप बोलते हो ये flow होता है जल्दी ये नहीं होता है. So that depends on the viscosity. So flow of liquid or flow of fluid can be expressed in terms of viscosity. Now what is it? It is nothing but the resistance to flow of the liquid. Higher will be the viscosity, greater will be the resistance to flow. We have already seen this. If you try to pour water from a bottle, it is easily pouring. You can easily pour the water. If you try to pour groundnut oil, you can also pour groundnut oil, but it will take a little bit more time as compared to water. If you try to pour a honey syrup, it will take much time because they are a viscous liquid and they will raise the flow. Syrup is having highest internal friction, okay, and it pours slowly. Now, what is viscosity? Again, nothing but the it is calculated by how to calculate the viscosity or dynamic viscosity. Shear stress. What is shear stress? That is nothing but the force per unit area applied on a stress. क्या होता है shear stress क्या होता है? It is nothing but the force per unit area which is applied on a liquid divided by rate of shear or velocity gradient. Rate of shear or velocity. What is that rate of shear or velocity gradient? That is denoted by a G. Okay, shear stress is denoted by F and shear rate is denoted by G. Now what is G? Velocity gradient. That is the change in the velocity. Okay, change in the distance. Okay, interplanar distance. So change in the distance. What is G? Change in the velocity with respect to the distance. Okay, change in the distance with respect to time. There is nothing but the velocity. So you can say, okay, you can say the equation is nothing but the shear stress is directly proportional to the rate of shearing. Now F is directly proportional to the G. So if you solve that equation, you have to take one constant, and that is nothing but the this constant. This constant is nothing but the eta. अगर आपने ऐसा लिख दिया F is directly proportional to the G. F is directly proportional to the. So you have to solve this. For that you have to take a constant. That is nothing but the eta. So okay. So viscosity. What is the formula for viscosity? Viscosity is nothing but the eta is equal to F upon G. That is the formula for viscosity. Okay. That is the formula for viscosity. So it is nothing but the viscosity. We have seen this. Now coefficient of viscosity is nothing but the same thing. There is a force per unit area required to maintain a unit difference in the velocity between two parallel layers of a liquid which are placed at a distance. Now liquid is composed of a liquid can be considered as a made up of different layers. Yeah. तो अगर liquid है, so these are okay, you can see. So if it is okay, so liquid or fluid is made from a different planes. Now if you apply a stress, अगर आपने यहाँ से force apply किया, if you apply stress, so each plane will slide on each other. Where each plane will slide. Now distance between the plane A, say for example upper layer क्या है plane A क्या है plane B. Distance between plane A is nothing but the dr. Okay, and and then velocity gradient is given by dv by dr. dv by dr. That's why F divided by G. Okay, there is a viscosity. Now unit is nothing but the poise and centipoise. Centipoise is nothing but the poise into 10 raised to minus 2. Now Poiseuille has contributed a great contribution in the study of rheology. That's why based upon his name, the poise is the unit. Okay. Now poise is defined as the that is nothing but the same thing. Poise is also defined as the whatever definition of viscosity is there, same definition is there of poise. So it is defined as the shearing force required to produce a velocity of 1 meter per second, okay, in two parallel planes of liquid of each 1 centimeter square area at a distance of 1 cm. Now viscosity of certain organic solvents, benzene has a 5.816, toluene has a 3.388, carbon tetrachloride 8.682, methanol has a 5.354. Okay, like that. At a 293 Kelvin, मतलब same. सेंटीपोज में कितना है? इथेनॉल has a 1.2 सेंटीपोज, ग्लिसरीन has a 1490. देखो ग्लिसरीन का विस्कोसिटी बहुत ज्यादा है. वाटर has a 1.01. okay, वाटर का याद रखना है सेंटीपोज. वाटर has a 0.01 सेंटीपोज विस्कोसिटी. Now blood plasma has a 1.5, whole blood has a. Now what do you mean by fluidity? So fluidity means if you are saying this liquid is free flowing, okay, fluidity is nothing but the reciprocal of your viscosity. जितना ज़्यादा viscous liquid रहेगा उतना उसका fluidity कम रहेगा. So viscosity and fluidity, they are inversely proportional to each other. So fluidity is nothing but the reciprocal of viscosity. Fluidity is nothing but the reciprocal of viscosity. Viscosity is denoted by eta word. Okay, eta. So 1 by eta. Kinematic viscosity is nothing but the viscosity divided by density, expressed as a Stokes or centistoke. So most of the dispersion do not follow the Newton's law. Newton's law क्या है? Newton's law है कि F है ना, F is directly proportional to the, मतलब क्या है? So rate of shearing is directly proportional to the, है ना, shearing force is directly proportional to the rate of shearing. That is given by Newton's. And those liquids which follow this Newton's law, so they are known as a Newtonian liquid. And those liquids of fluid who do not follow this law, न्यूटन का लॉ जो फॉलो करता है उनको अपन बोलते हैं न्यूटोनियन लिक्विड, जो फॉलो नहीं करता उनको बोलते हैं नॉन न्यूटोनियन लिक्विड. न्यूटन का लॉ क्या है भाई? सो शेयरिंग स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू द रेट ऑफ शेयरिंग. मतलब जितना शेयरिंग स्ट्रेस बढ़ता है उतना रेट ऑफ शेयरिंग बढ़ना चाहिए इन प्रोपोर्शनल. बट अगर वो बढ़ता है तो दैट इज अ न्यूटोनियन लिक्विड ना, और वो फ्लो हो जाएगा. और नहीं बढ़ता है तो नॉन न्यूटोनियन लिक्विड. सो मोस्ट ऑफ द liquids or dispersion do not follow Newton's law. That's why they are known as a Newtonian liquid. Now viscosity is the term to describe the Newtonian liquid. जो viscosity term है आपका, it is describing the Newtonian liquid. For non-Newtonian liquid, you have to describe with the one other term known as the apparent viscosity. Another term you have to describe the apparent viscosity. प्रमोद सर, मी तुम्हाला एक सॅटर्डे असतो फोन करू. लेक्चर मध्ये थोडंसं करतो फोन करू. Right? So apparent viscosity is the term to describe the non-Newtonian fluid. Viscosity has different types of viscosity are there. So first one is the relative viscosity. What is the relative viscosity? Relation किसमें होता है? दो जन के बीच में होता है ना, कि एक के जन के बीच में रिलेशन नहीं होता, रिलेशन दो बीच में होता है. रिलेटिव जब भी आएगा, रिलेटिव मतलब रिलेटिव फोर्स और रिलेटिव, है ना, रिलेटिव डेंसिटी, रिलेटिव विस्कोसिटी, तो दो इसकी कंपैरिजन आएगा. सो व्हाट इज रिलेटिव विस्कोसिटी? अगेन इट इज अ रेशियो ऑफ विस्कोसिटी ऑफ डिस्पर्शन टू दैट ऑफ द विस्कोसिटी ऑफ व्हीकल, है ना. जो डिस्पर्स फेज होता है उसका डेंसिटी कितना है, जो डिस्पर्स फेज है उसका विस्कोसिटी कितना है, और जो डिस्पर्शन मीडियम है उसका कितना विस्कोसिटी. सो रेशियो ऑफ विस्कोसिटी ऑफ डिस्पर्शन or disperse phase to the dispersion medium, that is nothing but the relative viscosity. Okay, so it is denoted by rho r, that is eta divided by eta 0. Eta is nothing but the viscosity of disperse phase, and eta is the viscosity of dispersion medium, and it is a disperse phase. Okay, disperse phase eta or dispersion, and the solvent is nothing but the eta 0. Okay, so relative viscosity. Then specific viscosity. तो specific viscosity क्या होता है? Relative increase in the viscosity of dispersion over that of the solvent alone. Specific viscosity is given is equal to, if you minus a relative viscosity, okay, 1 minus relative viscosity, 1 minus relative viscosity, 1 minus relative viscosity, 1 minus relative viscosity. So 1 minus eta divided by eta 0. If you solve that, it will come eta minus eta 0 divided by eta 0. So that is nothing but the specific viscosity. So you can say specific viscosity is nothing but the 1 minus relative viscosity. 1 minus relative viscosity. Then reduced to viscosity. So specific viscosity divided by concentration. ये जो specific viscosity है divided by concentration, that is known as a reduced to viscosity. Then intrinsic viscosity. So reduced to viscosity at a different concentration, reduced viscosity of different concentration of a substance that is measured and it is plotted. Plotted means viscosity against the concentration. That plot is made and the concentration at zero, whatever y-intercept is there, that is nothing but the intrinsic viscosity. The intercept value is known as intrinsic viscosity, and it is used in the determination of molecular weight of polymer. The intrinsic viscosity is given by this term. ये m नहीं है यहाँ पे intrinsic viscosity means eta kma molecular weight. These terms again I would like to explain you the last slides. ये मैंने आज भी अलग से दिया है. Now factors affecting on the viscosity. There are two factors, intrinsic factor and extrinsic factor. तो intrinsic मतलब अंदर के कौन से फैक्टर होते हैं मॉलिक्यूल के अंदर के. तो all these are known as intrinsic factor. So in that you are going to have chemical nature, molecular weight. Okay, molecular weight. If molecular weight is increased, so obviously viscosity will increase. So molecular weight is directly proportional to the viscosity of liquid. You have to remember. जिसका viscosity बढ़ता है, उसका molecular weight भी जाता है. So nature, then molecular weight, chemical nature, then molecular weight, then shape, size. Irregular shape अगर होगा, irregular size होगा तो liquid has a liquid will be viscous than symmetrical pattern. Okay. Intermolecular process. If more intermolecular processes are there, more will be the viscosity, right? Now then again extrinsic factor. So extrinsic factor, for example, temperature, pressure. So temperature is inversely proportional to the viscosity. Temperature बढ़ाएंगे तो viscosity कम होता है. Pressure बढ़ाएंगे तो viscosity बढ़ता है. So viscosity is directly proportional to the pressure because pressure will increase the cohesive force and more interaction. Viscosity will also increase. Viscosity is also increased by small amount of non-electrolyte like sucrose, glycerine, alcohol, and small amount of electrolyte, which will decrease the viscosity. Viscosity के देखो temperature बढ़ाएगा viscosity कम होगा. Temperature is inversely proportional to viscosity. Pressure is directly proportional to the viscosity. Pressure बढ़ेगा तो viscosity बढ़ता है. ठीक है. Then it is increased by addition of small amount of non-electrolyte. Non-electrolyte कौन से जैसे sugar, sucrose, glycerine, alcohol. And viscosity is decreased by small amount of strong electrolyte. So these are the factors affecting on a viscosity. ये फास्ट ले रहा हूँ क्योंकि कल लिए हैं आपने ऑलरेडी. Just trying to revise it. Now those liquid which follows the Newton's law, they are known as a Newtonian liquid. And if you try to plot a shearing stress versus rate of sharing, sharing stress versus rate of sharing, मतलब ये force and rate of sharing. Okay. Now for Newtonian liquids, so you know that F is directly proportional to G. So that's why in that proportion, if you increase the stress, so sharing rate also is increased proportionally. That's why you are going to get a straight line graph. Okay? It is also known as a consistency curve or rheogram. Okay? इसको ही अपन rheogram बोलते हैं, consistency curve बोलते हैं. Now the slope of this, okay, slope of this line is nothing but the fluidity. Okay, and this is the consistency curve or rheogram for Newtonian liquid. So that, okay, if you increase the stress shear rate will increase and there will be beginning of flow. Okay, beginning of flow for Newtonian liquid. For example, water, glycerine, alcohol, whatever, colloidal dispersion. They are the example of Newtonian fluid. Now, most of the fluid or liquid does not obey the Newton's law, and that's why they are known as non-Newtonian liquid. Non-Newtonian liquid. Non-Newtonian liquid. So what the term viscosity is used to describe this Newtonian liquid. Newtonian liquid can be described in terms of viscosity, but to describe the non-Newtonian liquid, you have to use another term known as a apparent viscosity. यहाँ पे apparent viscosity term use करते हैं. ठीक है. Now in that you have different type of flow. So first one is a plastic flow. Plastic flow. The material which are showing the plastic flow. Now in this case, if you apply a stress, if you plot a stress versus a rate of sharing, well, so if you apply a stress, so these plastic material showing plastic flow or body showing plastic flow, oh, they will not start flowing. They will not start flowing. So if you apply a stress, so it will take some stress. Okay, so you can easily see there is some amount of stress is required. Well, some amount of stress is already there required to the material, and it will not start flow immediately upon application of stress. It will absorb some kind of force. Okay, now it will start flowing somewhere. Okay, somewhere, some amount of force it will take, and after that it will start flowing. Okay, and if you, okay, then it will start flowing. Now if you if you see the intersect on शेयरिंग स्ट्रेस एक्सिस, एक्स एक्सिस पे जो शेयरिंग स्ट्रेस उसका एक इंटरसेक्ट ले लो, तो उससे समझ में आता कि इतना अमाउंट ऑफ स्ट्रेस जो इतना है जीरो से लेके यहाँ तक, ये स्ट्रेस तो ऑलरेडी लगाया आपने, ये इतना फोर्स लगाया फिर भी फ्लो नहीं हुआ, और दैट फोर्स इज नथिंग बट द यील्ड वैल्यू, दैट फोर्स इज नथिंग बट द यील्ड वैल्यू. सो व्हाट इज दैट? That force is the yield value. So yield value means force of flocculation. Force of flocculation. Yield value मतलब force of flocculation, and that's why this type of flow is given by flocculated suspension. This type of flow is shown by flocculated suspension. Now in the plastic flow, material showing plastic flow, they will not start to flow upon application of stress, but after some amount of stress, so they will start flowing. And that is nothing but the yield value, force of flocculation. So after crossing your yield value, then there is a flow of such kind of material, that is nothing but the plastic flow. And so slope is nothing but the slope slope of slope of this line is nothing but the mobility of this. Example मैंने बोला है material showing plastic flow, there is nothing but the flocculated suspension. Okay? Flocculated suspension and some gels. Okay, second आता है non Newtonian fluid में pseudo plastic flow. So in that, if you plot a shearing stress versus a rate of shearing, we will get a one graph. So that will start from the origin, this graph. Okay, if you apply stress, so such kind of material, what will happen with the such kind of material? The material showing pseudoplastic flow. So if you apply the stress, तो stress apply किया तो क्या होता है उनमें? So there is a decrease in the viscosity of that solution. Okay, so the material showing pseudoplastic flow, if you apply stress, so no doubt they will start flowing, but the viscosity will decrease and their flow will increase, their flow will increase. So they are known as a shear thinning system, they are known as a shear thinning system, because there is either decrease in the volume or decrease in the viscosity of such kind of material. If you apply stress, तो इनको stress apply किया तो इनका viscosity कम होता है, that's why curve is like this, curve is like this, right? So material showing the pseudoplastic flow is nothing but the polymer in the solution. So polymer of acacia, polymer of tragacan, polymer of your okay tragacan, then आपका जो methyl cellulose है carboxy methyl cellulose. So all these polymers, simply polymer in the solution, they will show pseudoplastic flow. Okay, flocculated suspension, they will show the plastic flow. Flocculated suspension, they will show the plastic flow, and polymer in the solution pseudoplastic flow. Now dilatant flow is another type of non-Newtonian behavior. तो नॉन न्यूटोनियन बिहेवियर एक होता है dilatant. So dilatant से में क्या होता है? If you apply stress, so shearing stress will also increase, but that is a disproportionate. So more shearing rate will be increased. Okay? So the curve is like this. So what happens with this kind of material? The material showing dilatant flow, if you apply stress, so what happens? There is increase in the volume of that material. There is an increase in the volume and viscosity. इनमें क्या होता है? वॉल्यूम एंड विस्कोसिटी क्या होता है? इंक्रीज होता है. pseudoplastic में क्या होता है? डिक्रीज होता है. If you apply stress, in the volume and viscosity in the pseudoplastic material, that's why they are known as shear thinning system. They are known as shear thinning system. They are known as shear thinning system. But dilatant flow, material showing dilatant flow, they are known as a shear thickening system. Shear thickening system. Okay, shear thickening system. Okay, some of the non-Newton fluid. Okay, yeah, they also thixotropic material. They are known as thixotropic material. Some non-Newtonian fluid, if you plot a stress rate of shearing, shear stress versus rate of shearing, so you will get such kind of curve. Okay. So initially, if you apply stress, they will begin to flow, and there is a bulging on the up curve. So this is known as the up curve. This is known as the down curve. Down curve will coincide with the up curve, but up curve will bulge out. So particularly magnesium icon. Magnesium magma, 10 to 15% solution of magnesium. Sorry, bentonite magma, 10 to 15% solution of bentonite magma. They will show you the bulge, particular bulge. Suspension of penicillin, suspension of penicillin in the suspension of broken penicillin. So if you apply stress, so that is also thiotropic material. Thiotropic क्या होता है अपन देखेंगे, बाद में फिर से बोलूँगा मैं आपको. So if you apply stress, so they will start flowing, but sharp changes are there. So again, this is known as spur. Okay, they will show the spur. तो इसका इसके ऊपर क्वेश्चन आता है कि in the rheogram spur is shown by broken penicillin G. Okay, then bulge is shown by bentonite magma. You have to remember. Okay, now we'll see the next point. I hope I am audible to you. I hope I am audible to you. Am I audible? Yes or no? Now fluids are classified into two types: Newtonian fluids and non-Newtonian fluids. Newtonian fluid means they will obey Newton's law. Newton's law का है rate of sharing is directly proportional to sharing stress is directly proportional to the sharing rate of sharing. F is directly proportional to the G. F is directly proportional to the G. That is Newtonian. And those liquid which will follow Newton's law, known as Newtonian liquid, water, then water, glycerin, then your methanol, etc., etc. Non-Newtonian in that there are two types: time dependent behavior, so time dependent flow. So in case of plastics, slow plastic flow and dilatant flow. So time dependent behavior. Time independent behavior is there in case of thixotropy, anti-thixotropy or negative thixotropy, and rheopexy. So these are the different behaviors. Now temperature, the factors affecting on the viscosity. We have seen temperature is inversely proportional. The increase in the temperature will decrease the viscosity. Increase in the temperature will decrease the viscosity due to breaking of cohesive bond. So जैसे temperature बढ़ता है तो interparticular bonds होता है वो break होता है, and because of that breaking of interparticular bond, so there is a decrease in the viscosity. Newton was the first who studied the flow properties of fluids, and that has given this equation. Is uh, F is directly proportional to the G, and that's why you have to take this rate constant known as eta, and it is nothing but the viscosity. So viscosity is equal to F divided by G. So rheogram are nothing but the consistency curve or rheogram. They will show the relationship between shear stress and rate of shearing. Newtonian fluids will obey the Newton's law. What are the examples of Newtonian fluid? Question आ चुका है इसके ऊपर. Water, glycerin, chloroform, solution of syrup, very dilute colloidal solution. So they are the example of Newtonian liquids. So viscosity is the term which is used to describe the Newtonian liquid. Non-Newtonian liquid क्या होता है? They will not obey the Newton's law, and that's why. Okay, example क्या है? Heterogeneous dispersion like suspension, emulsion, semi-solids. They are grouped into this non-Newtonian liquids. So apparent viscosity is the term which is used to describe the non-Newtonian liquid. Now plastic flow. Plastic flow means it is one of the non-Newtonian liquid. So we have seen the consistency curve. So consistency curve is not passing through origin, and initially substance will be like elastic body. Okay, elastic body, and when stress limit is when the sufficient amount of stress is applied, so increase in the stress leads to non-linear increase in the shear rate, and then progressively it will get linearized. So at the certain point, that is known as a yield value. Okay? So yield value is nothing but the intersect on x-axis, which is a linear. Well, if you plot a linear portion of that consistency curve in the pseudoplastic flow on x-axis, so that point is known as a yield value. What is yield value? Yield value is nothing but the force of flocculation. Plastic flow can be expressed in terms of yield value. That is a force of flocculation. Means in the suspension, force of flocculation is given at a yield value. प्लास्टिक विस्कोसिटी, उसको प्लास्टिक विस्कोसिटी मतलब लीनियर पोर्शन जो है उसको प्लास्टिक विस्कोसिटी बोलेंगे. Now plastic flow is because of the presence of floccles, that is the aggregation of particle in the concentrated suspension. So butter, plasters, gels and certain ointments, they will show you plastic flow. याद रखना है उसको. क्वेश्चन आता है yield value is nothing but the It is a stress required to break the interparticular contact so that the particle behave individually. जब एग्रीगेशन होता है तो पार्टिकल में बॉन्ड फॉर्म होता है ना? तो जब एग्रीगेशन होता है तो बॉन्ड फॉर्मेशन, तो इनिशियली आपने स्ट्रेस अप्लाई किया है तो मटेरियल क्या है, बिहेव करता है इलास्टिक लाइक बिहेव करता है, तो वो फ्लो नहीं होता, वो रेजिस्ट करता है, इट विल टेक सम स्ट्रेस एंड आफ्टर, है ना, उसका, है ना, आप अगर कोई आपका हाथ खींचता है तो आप में जितनी ताकत है उतनी ताकत जब लगाते हो आप, तो आपका हाथ आप जगह से हिलते नहीं हो, जब आपको कोई खींच रहा है तो आप में भी ताकत है ना, आप थोड़ी ऐसे, तो आपको कोई हिलता नहीं, लेकिन उसने अगर बहुत ज्यादा ताकत ले लिया, लगा दिया, फिर आप उसकी तरफ खींच के जाते हो, ठीक है ना? तो वैसा yield value, that is the stress which is absorbed by this material, and after the particular stress, it will there is a breaking of structure of plastic material, material showing plastic flow, and then there is a flow, okay, that is known as a plastic, which is the indicator of force of flocculation. Remember, क्वेश्चन इसके ऊपर आ चुका है, कल ही मैंने बोला, material showing the plastic flow, they are also known as the Bingham bodies. तो इसके ऊपर भी एज इज क्वेश्चन है, मटेरियल शोइंग प्लास्टिक फ्लो दे आर नोन एज Bingham bodies. Those material which show plastic flow they are known as Bingham bodies. Yield value will be high in case of flocculated suspension, and in case of deflocculated suspension yield value will be zero. Yield value zero होता है deflocculate में, जिसमें floccule है उसमें yield value क्या रहेगा, high रहेगा. Yield value is high in case of flocculated suspension, and in case of deflocculated suspension yield value will be nil or zero. Hello. Then pseudoplastic flow. So we have seen the consistency curve. So pseudoplastic flow will start at the origin near at a zero. Increase in the shear stress will increase the shearing rate proportionally, and it cannot be explained by single value. It cannot be explained by single value because, okay, after increasing the shear, the viscosity of that material will decrease. That's why it is known as shear thinning system, pseudoplastic flow. So equation which will represent the curve is nothing but the f raised to n eta g. N is the integral. Now in the pseudoplastic flow, the value of n is more than 1. एक से ज़्यादा value होगा. In the pseudoplastic flow, n is more than 1. N is greater than 1. In the, okay, in the more will be the value of n. More will be the pseudoplastic behavior of material. If n is equal to 1, n अगर एक होता है, that will become a plastic flow. That will become a plastic flow. And if n is equal to 0, if n is equal to 0, 0 अगर है, n is equal to 0, so that is nothing but the Newtonian liquid. So n is equal to 0 means Newtonian liquid हो जाएगा. n is equal to 1 means pseudoplastic behavior हो जाएगा. n is more than 1 means, है ना, n is more than 1 means pseudoplastic behavior. n is equal to 1 means plastic behavior. n is equal to 0 means Newtonian liquid. n is equal to 0 Newtonian liquid. n is equal to 1 plastic liquid, and n is more than 1 pseudoplastic. Pseudoplastic flow is shown by polymer in the polymer dispersion, like dispersion of tricant, then sodium alginate, methyl cellulose, sodium methyl cellulose, sodium carboxymethyl cellulose. Pseudoplastic flow is shown by these material. Then next होता है dilatant flow. Dilatant flow is nothing but the, we have seen the consistency curve. If you apply stress, so there is a increase in the resistance to the flow. If you apply stress, there is an increase in the resistance to flow. In case of pseudoplastic, उसमें apply किया stress तो flow बढ़ जाता है, because decrease in the viscosity. So there is increase in the flow, okay, and it cannot be expressed by single value. But in case of dilatant flow, if you apply stress, or if you, in case of dilatant, okay, if you, in case of material showing dilatant flow, if you apply stress, there is an increase in the viscosity or volume. That's why it is known as shear thinning, so shear thickening system. Okay, so if you apply stress, there is increase in the volume because of the applied stress. This system, that's why they call as a dilatant or shear thickening system. तो इसके ऊपर भी क्वेश्चन आता है, which one is shear thinning, which one is their thickening. Okay, now because why it is known as shear thickening, because increased apparent viscosity at a higher shear rate, a system returns to its original state of fluidity when stress is removed. जब stress remove होता है तो जो सिस्टम है वो ओरिजिनल उसका फ्लूइडिटी में आता है. इक्वेशन इसके लिए क्या है, f raised to n eta into g, that is the equation, and n is less than 1 for this dilatant flow. n is less than 1 for dilatant flow. If n is equal to 0, that is Newtonian liquid, it will become Newtonian liquid. If N is more than 1, it will become a pseudoplastic. So degree of dilatancy will increase. So less will be the value of N. वो एक से बहुत कम हो रहा है, जितना जितना कम हो जाए उतना डायलेटेंसी बढ़ जाएगा. Dilatancy or shear thickening system. So plastic means shear thinning system. Dilatant flow is shown by a suspension having more than 50% solid content. Okay, a suspension with a high concentration of solid, more than 50%, it will show the dilatant. Suspension of starch in the water will show the dilatant flow. 12% kaolin suspension in water will show the dilatant flow. 30% zinc oxide suspension will show the dilatant flow. You have to remember. Okay, question इसके ऊपर आ चुके बहुत सारे आते हैं. और sediment in case of flocculators जो suspension होता है, suspension may be either flocculated or deflocculated. Floccules मतलब क्या है? Floccules मतलब aggregation of particles. Aggregation of particles. So there is a formation of loose aggregation of particles in the suspension known as a floccules. Now floccules बनना अच्छी बात है because if there is a formation of floccules, you can easily redisperse that floccules. Okay? But if there is a suspension is a deflocculated, if there is no formation of floccules, so what will happen? There is a settling of particles and there is a formation of hard key. So in case of deflocculated suspension, dilatant, okay, deflocculated suspension is a dilatant and will resist the any attempt of stirring. Okay, तो flocculated suspension होता है और उसको स्टर किया आपने तो वो इजीली रीडिस्पर्स होता है. लेकिन अगर deflocculated suspension में जो केक बनता है वो अगर आपने शेक किया so that will not redistribute. So okay, so sediment in case of deflocculated suspension is dilatant and will show the dilatancy, will resist the any attempt of stirring. Okay, and shaking. For shaking effect is called as a caking or claying in the suspension. Now thixotropy क्या होता है? Thixotropy again very very important है. Thixotropy के ऊपर क्वेश्चन बहुत बार आ चुके हैं. Thixotropy is nothing but the when shear thinning system कौन है? Pseudoplastic. When shear thinning system it is a kept aside. Okay, when shear thinning system is a agitated मतलब स्टरिंग किया उसको. स्टरिंग किया मतलब क्या है? एजिटेशन मतलब स्टरिंग मतलब क्या है? इफ यू ऐड अ स्ट्रेस, एजिटेट किया मतलब स्टर किया मतलब क्या है? स्ट्रेस अप्लाई किया. So shear thinning system or plastic material, if it is stirred and kept aside, it will return to its original state of fluidity, but it will take longer time to recover as compared to the time of agitation. Now this behavior is known as a thixotropic behavior. This behavior is known as a thixotropic behavior. स्टोप्लास्टिक मटेरियल है, उसको अगर आपने एजिटेट किया है ना, स्टोप्लास्टिक मटेरियल है, उसका एक पर्टिकुलर फ्लूइड स्टेट है, फ्लूइडिटी, एंड उसको अगर आपने शेकिंग किया, स्ट्रेस अप्लाई किया, ओके, तो उसका क्या है? फ्लूइड स्टेट चेंज हो गया, फ्लूइड स्टेट चेंज हो गया. ओके, नाउ if you kept it aside, so it will regain its original state of fluidity, but it will take a time and it is a more than time of agitation. जितने टाइम आपने स्टार्ट किया उससे ज़्यादा टाइम लेगा. Now this behavior is known as a thixotropy. What is thixotropy definition? So it is nothing but the isothermal and comparatively slow recovery of a standing of material of consistency with isothermal and comparatively slow recovery on standing of material of a consistency loss through a stirring. जो भी मटेरियल है उसका स्टर करने के बाद कंसिस्टेंसी लॉस हो गया, ओके, वो रिकवर हो रहा है लेकिन टाइम ले रहा है, कंपैरेटिवली स्लो रिकवरी. दैट इज नथिंग बट थिक्सोट्रॉपी. और थिक्सोट्रॉपी में क्या होता है? थिक्सोट्रॉपिक मटेरियल इज जेल. ओके, थिक्सोट्रॉपिक मटेरियल जो होता है वो जेल होता है, जेल. इट इज अ जेल. थिक्सोट्रॉपिक मटेरियल इज अ जेल एंड इफ यू अप्लाई स्ट्रेस सो इट विल बिकम अ सोल. तो है ना, स्यूडोप्लास्टिक देखो ना, तो उसको अगर स्ट्रेस अप्लाई किया तो उसको विस्कोसिटी कम होता है, जेल का विस्कोसिटी ज्यादा होता है, सॉल्यूशन का कम होता है. सो जेल विल बी कन्वर्टेड इनटू सोल एंड इफ यू रिमूव द स्ट्रेस अगेन सोल विल बी कन्वर्टेड इनटू जेल. सो थिक्सोट्रॉपी इज नथिंग बट द जेल सोल जेल ट्रांसफॉर्मिंग फिनोमेना. ओके, जेल सोल जेल ट्रांसफॉर्मिंग फिनोमेना. शेयर थिनिंग सिस्टम, शेयर थिनिंग सिस्टम क्यों बोलते हैं? बिकॉज इसमें क्या हो रहा है? विस्कोसिटी जो है ना वो कम हो रहा है. upon application of stress viscosity will decrease. Okay? So initially thisotopic material is a gel, at rest is gel. If you apply stress it will become a sol, and if you remove the stress it will again become a gel. Now transformation phenomena, So gel sol gel transformation is nothing but thesotropy. इसके ऊपर भी क्वेश्चन आते हैं बहुत सारे आ चुके ऑलरेडी. Shear 3 system. It is a gel at rest. Okay, gel has a high viscosity. Gel has a high viscosity and multi-point contact. Now applied shear rate apply किया, stress apply किया, it will become a sol low viscosity. And after removal of stress, again it will become a gel. Again it will establish the contact due to Brownian motion. Is a high viscosity. Okay, that is a high viscosity. So thixotropy is nothing but the gel sol gel phenomena. You have to remember gel sol gel phenomena. Now bulges thixotropic some thixotropic material, for example concentrated magma, concentrated aqueous magma, okay, aqueous magma of bentonite, 10 to 15%. Now it will produce a particular, okay, it will produce a particular like this. So bulge, it will produce a bulge. So that curve is known as a hysteresis loop. It is known as a hysteresis loop and characteristic bulge in the up curve. तो up curve ये होता है, up curve ये होता है जाने वाला curve, down curve ये होता है. up curve में क्या है, bulge मिलेगा आपको, okay, stress and shearing rate. Okay, so this is known as a bulges. Okay, this is known as a bulges. So bulge is shown by aqueous magma or aqueous magma of bentonite, 10 to 15% solution. So suspension, 10 to 15% suspension of bentonite magma will show the bulges. Spur is shown by broken penicillin. With spur is shown by penicillin gel. But diagram here, bulge curve may actually develop in a spur like protrusion. Now negative thixotropy क्या होता है? Negative thixotropy. Thixotropy मतलब क्या है? Slow and comparatively, okay, slow recovery after the deformation. Comparatively slow recovery, isothermal and slow recovery. Okay, consistency loss through application of stress. That is a thixotropy. Negative thixotropy मतलब क्या है? इसको अपने बोलते हैं एंटी thixotropy. नेगेटिव थियोसॉफी और एंटी थियोसॉफी. थियोसॉफी में क्या हो रहा था? थियोसॉफी में जेल will become a soul and after removal of stress will become a gel again. That is a thixotropy. Now negative thixotropy में क्या होगा? Negative thixotropic material is, okay, it is a soul at rest solution होता है. If you apply stress, it will become a gel. It will become a gel. And if you remove the stress, again it will become a soul. Anti-thixotropy. Increase in the consistency of down core magnesium magma shows increased resistance to flow. It increased the time of shear as compared to the resistance. It known as a negative thixotropy. इसके अगेंस्ट में आता है negative. Now it is known as a soul transformation. तो इसके ऊपर क्वेश्चन आता है आपको, कौन सा सोल जेल कन्फर्मेशन है, ट्रांसफॉर्मेशन है, कौन सा सोल है. So thixotropy is a soul gel conformation. Okay, gel transformation thixotropy. And in case of negative thixotropy, soul transformation. क्वेश्चन बहुत बार आ चुके हैं. नेगेटिव thixotropy is seen in the flocculated suspension containing low solid content. फ्लोकुलेटेड सस्पेंशन होता है विद द लो सॉलिड कंटेंट, उसमें ये है ना, इसमें ये होता है. देन होता है नेक्स्ट टर्म इज रिगोपेक्सी. इसके ऊपर भी जीपैट 2021 में क्वेश्चन आ चुका है. द फिनोमेनन इन व्हिच सोल ट्रांसफॉर्म इनटू जेल state more rapidly just by gently shaking or application of low shear than keeping in a soul state. Okay, so soul is transferred into gel just by simple gentle shaking. थोड़ा सा ही आपने स्ट्रेस अप्लाई किया तो वो जेल का सोल बन जाएगा. दैट इज नथिंग बट द रिगोपेक्सी. दैट इज नथिंग बट द रिगोपेक्सी. इसके ऊपर भी क्वेश्चन आ चुका है. रिगोपेक्सी, थिक्सोट्रोपी, नेगेटिव थिक्सोट्रोपी, मटेरियल शोइंग द प्लास्टिक फ्लो, मटेरियल शोइंग द pseudo-plastic flow, material showing the dilating flow. Now, application of this rheology. So it is desirable property in case of immersion suspension and cream. Okay, greater the thixotropy, greater will be the physical stability of suspension. Degree of thixotropy is related with the specific surface area in case of penicillin used. Okay, now selection of viscometer. Selection of viscometer. So material, the instrument which is used to measure the thixotropic behavior known as a